In this video, we're going to be talking about 5 common laboratory techniques that you can use to separate mixtures into their individual components. These are not the only separation techniques that exist. These are just 5 common ones, and during the course of the year, we'll use 4 of them definitively, and I'll probably show you an example of the 5th. You will need your notes, you will need something to write with, and when you have those ready, let's go. So our first separation technique is actually the simplest separation technique of all. It's what's called decanting. Decanting, all you do is you pour off the top layer of a mixture. Right? So we have a heterogeneous mixture here because what you have is you have a solid layer on the bottom and you have this liquid layer on top. We're going to pour off the top liquid layer, or at least most of it. You don't have to pour off all of it. You can do it either by pouring. Now, a good way to decant if you're pouring, by the way, is use a stirring rod and pour down the rod. That way it mixes so it doesn't splash everywhere. Or you can use something like a pipette. Or if you're at home, for example, and you want to decant, like let's say you're making stock, one of the things you have to do is remove the fat layer, which goes up to the top. All you do there is just take a spoon and you spoon it off little bit by little bit until you get it off. Right, so all you're doing is you're taking off the top layer. You don't take off all of it, you take off most of it because you'll never get all of it off. And the reason why you decant generally to make it so that later separation techniques actually take less time. Okay, you use this very often before you filter things. Okay, so if I wanted to filter everything in that beaker up top, if I were to pour that through a filter, it may take an hour or two. But if I decant 80% of the liquid first, then my hour or two becomes maybe 10 or 15 minutes. And that becomes a lot more manageable. Right, so decanting, simplest separation technique. It's crude, but it works. Our next separation technique is one you're very familiar with. This is filtration, right? If you've ever made coffee, you've done filtration before. The idea behind filtration is that you pour a mixture through a piece of filter paper, right? That filter paper is folded. There are different ways to fold it. I'm going to show you one of the more common ones, which is the one that they have in this example here. And what's going to happen is that anything that is soluble in water will pass through the filter paper into the bottom into what's called the filtrate, which is what we collect in the beaker below. Anything that doesn't dissolve in water, any precipitate, gets left behind in the filter paper. Right? So when you make coffee, what you do is you're taking the coffee mixture, you're pouring it through a filter. Right? Anything that will dissolve in the water passes through the filter into the pot, and the filtrate is your coffee. The coffee grounds, or whatever parts of the coffee grounds won't dissolve in water, remain in the filter paper separated. All right, this is a great separation technique to use if you want to separate solids out of a mixture. Now, one thing to keep in mind, as they've shown here, the filtrate that you have below should be crystal clear. If it has any hint of the precipitate in it, you have to start over again. Our third separation technique is evaporation. This again is a fairly easy one, but it's effective. Evaporation is exactly what it sounds like. What you do is you heat a solution very gently. Now you can either heat it up on a hot plate or on a Bunsen burner, or what they're doing here to collect salt is they're letting the sun heat up the water and evaporate the water out of the salt. Right, so what will happen is all the liquids will evaporate and it only leaves the solids behind, and you can collect the solids. Right, so in a laboratory setting, what you would do is you would heat in something called an evaporating dish. It's basically like this little porcelain bowl. On top of that evaporating dish, you would put a watch glass. Looks like a giant glass contact lens. What the watch glass does is the watch glass prevents splatter. That's something you have to watch for, right? That's why you want to go slowly, because if you heat it too much, it will splatter, you lose solid. A watch glass helps you keep that solid there because it will actually catch it as it hits. Right? And what happens is any liquid or solvent is driven off, and all of the dissolved solids are now in solid state, and you can collect them. Right? So that's evaporation. Our next separation technique is what's called distillation. Distillation is one that you see used in industry a lot. What you do is you take a mixture, you heat it extremely slowly. And what's going to happen is that it's going to separate out by its boiling points, right? So if I had, for example, alcohol, which boils at like 85 degrees, and water, which boils at 100, if I heat it really slowly, once the mixture reaches 85 degrees, the alcohol will start vaporizing. When it vaporizes, it will travel up the vertical tube. That's what's called a separation column. And then it will go into the column on the right. The column on the right is actually a double-walled column. The interior column carries the vapor. The outside column is filled with cold water. That tube right there is what's either called a condensing chamber or more commonly a condensing tube. What happens is that the gas, as it travels down that tube on the right, comes into contact with the cold water. The cold water causes the gas to condense back into a liquid, and the liquid drips out the other end and is collected. Right, so if I have my alcohol mixture, alcohol is coming across at 85 degrees, goes down the condensing tube. The tube comes into contact with cold water, which causes the alcohol vapor to condense back into liquid, and the now pure alcohol drops into the flask on the right and is collected. If I let it keep going, what will wind up happening is once the temperature reaches 100 degrees, so it'll stay at 85 until all the water is gone, or all the alcohol is gone, then it will keep rising. Once it gets to 100, it will then start distilling the water itself. Right, so you can separate things by their boiling points by using distillation. The last separation technique we're going to use, and this one I'm going to give you a couple of options on how you want to do it, is called chromatography. Some of you may have done chromatography last year in bio with, I believe, the strawberry, where you put it in and you saw it separate into different components. Right, the idea behind chromatography is that if you have a mixture that has different components in it, those components are going to have an attraction to either the solvent that you're using. So if we look at the diagram on the right, you have a piece of paper that's called chromatography paper. That's what's called our stationary phase. So that's the phase that's not moving. And then at the bottom, you have that liquid. That solvent right there, that liquid, is what's called the mobile phase, because what's going to happen over time is it's going to get wicked up that paper just like water does on a paper towel. Now, each of those four dots, the components in each of those dots have different attractions for the solvent, so for the liquid that's rising, and for the paper. The more attracted they are for the liquid, the higher they're going to rise as the liquid travels up. Okay, so what we're going to do is we're going to separate mixtures by that attraction. So the more attracted it is to the solvent, the faster it moves up. And what we'll see is as you go up, it separates more and more and more. So if we look at the one on the right, the image on the right, if we look at, for example, the third dot, we have two distinct lines, right? We have a purple dot down bottom, a blue dot up top. The one next to it on the left, we have a little yellow band on the bottom, a blue band on top. Those are the different dyes in the ink separating into their component colors, right? That second dot is green. Green is made up of yellow and blue, so it's separating into those two dyes. Chromatography is a great way to figure out what substances you have in a mixture by separating them out this way. You can do it with paper, which is what we have shown here, or you can do it with what's called a column, a packed column of resin, and that's called column chromatography. We'll be doing paper later this year, either as a clue game, or maybe we'll do it with like M&Ms or Skittles, and you can figure out what the food dyes are made out of. Okay, so like I said, those are common separation techniques. It's not an exhaustive list, and I will see you guys in class.